Hello everybody, my name is Cahill Carew. Today I'll be teaching you how to do stociometry. Let's start by reading the problem. The following equation occurs when 0.25 grams of CO3AS2 and 0.51 grams of K2S react to give you COS and K3AS. What is the limiting reactant? Now the first thing you want to do is write your equation. Your equation is CO3AS2 plus K2S react to give you COS plus K3AS. Now you're going to want to balance your equation. To balance your equation, you look at how much of an element you have on one side of the equation, how much you have on the other. Here you have cobalt 1, cobalt 3. So to balance it, you write 3 in front of this. Then you have 3 cobalt. You also have 3 sulfur. You only have 1 sulfur here. So you write 3 in front of this. But now you have 6 potassium, since 3 times 2 is 6. So you write 2 down here. Now you have 6 potassium here, 6 here, 3 sulfur here, 3 sulfur here, 3 cobalt here, 3 cobalt here, 2 arsenide here, and 2 arsenide here. So it all balances out. Now you have that written down. You want to find your molar mass. To find your molar mass, you want to appear our table and look to the top right hand corner. You'll then find your molar mass in bold letters. The molar mass of CO3AS2 is 326.67. The molar mass of K2S is 110.26. This is your molar mass of these compounds. CO3AS2 is 326.67, K2S 110.26. Now you go and find your molar mass. To find your molar mass, you take mass over molar mass. Enter your mass of these elements. Mass of these elements was told earlier. Mass was 0.25 grams of CO3AS2 and 0.51 grams of potassium sulfide, K2S. Now to find your moles, moles equals to mass over molar mass. And to find your moles of CO3AS2, moles equals mass over molar mass, which is then equal to 0.25 grams, and your molar mass of CO3AS2 was 326.67, I mean. And that should add up to give you 0.000765 grams a mole. And that's for CO3 AS2. Now, your moles of K2S equals mass or molar mass, which should be 0.51 grams of your molar mass K2S, which is 110.26. And that should equal out to give you 0.00462 grams a mole. Now that you have your moles of these, now you have your moles of CO3 AS2 and K2S, you can move on to find your moles of what you have on the other side of the reacting. You can actually choose one compound on the other side of your equation, but you have to choose wisely. You can only use that compound when you continue on. Now, to find your moles of COS, you take your moles of CO3AS2, which is 0.000742 moles of CO3AS2, and you then multiply them by the compound that you chose, which happens to be 3COS. You then divide by what else is on the left-hand side of your equation, which happens to be 3K2S. Oh, I apologize. I mean, you divide by what happens to be what you're multiplying by here, which is CO3 AS2. And you have 1 mole of that, as seen up here. These then cancel out, and you can multiply by 3 and divide by 1, which should give you 0.00226. That is your moles of COS. So your moles of COS. That's your moles of COS. Now you continue on. Like I said, you have used the same thing, but now you're using K2S over here. And your moles of K2S are 0.00462 multiplied by 3COS. Over here are your moles of K2S. You then divide by K2S so they cancel out. Remember, you use what you balance with it up here. These then cancel out, and you can multiply here. So 0.00462 multiplied by 3 divided by 2. And that should give you 0.00693. Now whatever is smallest is your limiting reactant. So which of these is smallest? This is smallest. So, the learning reactant is CO3 AS2.